Recently, there was a bombshell announcement in the scientific community that there's a bunch of smaller objects in the outer solar system that appear to be influenced by the gravity of a massive hidden ninth planet. So this planet is 10 times more massive than Earth. It's 100 billion kilometers away, and it takes 15,000 years to orbit the sun once. So I've seen some pretty impressive videos about the scale of the solar system, but they're all still pretty abstract because they're either using renderings of the planets or they're using objects and distances that have no real-world association. So I'm going to attempt to fix that today by representing the planets with just junk you could find lying around your house, overlaid onto this football field. So we'll start by reviewing the scale of the first 8 planets, and then I will attempt to blow your mind by showing you exactly how far away the newly predicted 9th planet is. If you ask how far away Earth orbits the sun, most people give an answer like this.
Right here, I guess.
And it's kind of understandable.
About right there?
Stop. Because every picture of the solar system ever looks like these, including my own report on the solar system from the 4th grade. So this is the true scale of the solar system, starting with our size 5 soccer ball sun, which puts Mercury at the 10-yard line as a mere fleck of pepper. Next is Venus at the 19-yard line, and it's about the head of a pin. Next up is my favorite planet, Earth, orbited by our grain of salt moon. So if you retain nothing else from this video, just remember that Earth is the size of the head of a pin, and it's at the 26-yard line. And as the final rocky planet, we have Mars at the 40-yard line, also a fleck of pepper. And now we start to see bigger gaps. At more than a football field away from our sun, we have Jupiter, which is the scaled size of a grape. And after a little bit of exercise, we come to Saturn, which is a slightly smaller grape, and 2.5 football fields away from our soccer ball sun. Next up is the 7th planet Uranus, which is the size of a pea, and its orbit is an average of 5 football fields away from our sun. And finally we come to Neptune, which is also the size of a pea and orbits around our sun the size of a soccer ball, nearly 8 football fields away. Now, this view should help you appreciate the difficulty in accurately representing both the size and distance between the planets in a single image. Okay, so before we get to the new 9th planet, let's recap. So we've got a pepper flake at the 10-yard line for Mercury, and then a pinhead at the 18-yard line for Venus, and then another pinhead for Earth at the 26-yard line, and then a pepper flake for Mars at about the 40. And then of course the asteroid belt, and then we make it to Jupiter, which is a grape at about 135 yards. Then we cross the street to get to Saturn, which is a grape that orbits at about 2.5 football fields around our soccer ball sun. Then we double our distance from the sun to get to the 7th planet, which is a pea at 5 football fields away. And finally, at nearly 8 football fields away from our sun, we have another pea, which is Neptune. And now we've laid the framework for understanding just how far away Planet 9 is. Because to reach it, I would need to walk, and to walk some more, and to keep walking at a brisk pace for 5.5 hours before I finally reached the P that is Planet 9. And while of course you can't see it, you'll just have to take my word that directly in front of us, 17.5 miles, or 309 football fields away, there's a yellow size 5 soccer ball sitting in an end zone. In fact, the width of that column you see represents the extent of our entire solar system as we know it today. From a different perspective, this would be your view if you parked your spaceship halfway to Planet 9. It blows my mind that, relatively speaking, our sun, 17.5 miles away, would be able to keep this pea in orbit. But what's just as fascinating to me is when you consider that in our scale model, the sun is represented by a soccer ball, which anyone could easily fit inside a soccer goal. And yet our massive star we call the sun is pretty small when compared to some other stars. In fact, the largest star we know, next to our soccer ball-sized sun, would be as tall as the Empire State Building. So I want to close by telling you guys the craziest thing I learned about space while working at NASA for 9 years. But before I do, I'd like to quickly thank Squarespace for helping make this video possible. So, true story, a couple of years ago while still working at NASA, I had a crazy idea for a Halloween costume. So I made an app and a YouTube video, and then I printed a metric buttload of t-shirts, and then I made a website where people could come and buy them. And by far, the easiest step in that process was making the website because I use Squarespace. It's still amazing to me that we live in a day where in less than an hour with no coding required, you can make a custom website that looks super professional, that people can buy stuff that you make from all over the world. So if you have an awesome idea you want to launch, or you just want to showcase your business or maybe a hobby, you go to squarespace.com/markrover for a free trial. And then when you're ready, you can use offer code MARKROVER for 10% off. Okay, so here's the coolest thing about space I know. 20 years ago, astronomers did something pretty risky and decided to point the Hubble telescope at the darkest patch of the night sky for 10 days. Now this was risky because time on the Hubble telescope was extremely limited, and there was a good chance the image would come back completely dark. So they started exposing the shot, and for 10 days, photons entered the telescope and ended their journey of billions of years on Hubble's CCD detector. And at the end of 10 days, this was the resulting image. With the exception of these single stars, every speck, smudge, and spiral you see in this image is a galaxy with hundreds of billions of stars, just like our own Milky Way. And what truly makes this mind-blowing is the portion of the sky represented in this image is the size of Roosevelt's eye on a dime, held at arm's length. To think about it another way, there are more stars in the universe than there are grains of sand on all the playgrounds, beaches, ocean floors, and deserts on our planet. So next time you're near some sand, take a handful and just imagine that one of those tiny grains is our sun with its orbiting planets. And then look at the hundreds of thousands of additional grains of sand in your hand, each with their own orbiting planets. And then while holding that, contemplate how many handfuls of sand exist on our planet. So in my mind, regardless of how you think this whole universe came to be, there seems to be an infinitesimally small chance that we're alone.